Dear students, the given question is, suggest the most important type of intermolecular attractive interaction in the following pairs. First, n-hexane and n-octane, iodine and carbon tetrachloride, NaClO4 and water, methanol and acetone, acetonitrile and acetone. So we are having here 5 pairs of molecules. So let us see one by one. The first one is, both n-hexane and n-octane are non-polar. If we see n-hexane is a non-polar molecule. All carbon hydrogen bonds are CH3, CH2, CH2. Let us write here CH3, CH2, 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 CH3. This is n-hexane. Now here we know carbon and hydrogen, their electronegativities are almost same. Therefore, the molecule is nonpolar. Like that, n-octane is also nonpolar. That means here the intermolecular interactions will be London dispersion forces, because the force, if the molecules are nonpolar, here you see these molecules are nonpolar, the electron cloud is uniform around the nucleus. The molecular orbital electron cloud is uniform around the nucleus. At some moment, what happens? Electron cloud becomes one side and the nucleus becomes one side. As a result, the molecule becomes temporarily polar. Then what will happen? That will make the other molecule polar, because this electron cloud of this molecule will repel the electron cloud of the other nearby molecule and attract the nucleus. As a result, the other molecule will become polar, and the attractive influence or attractive force starts acting between the electron cloud and nucleus of the other molecule. Therefore, this force is known as what? London dispersion forces. So, between two non-polar molecules, this type of force always occurs. Similarly, here iodine and carbon tetrachloride, we know iodine is a non-polar molecule. Here we have 0 charge. Similarly, carbon tetrachloride, it is having polar bonds, no doubt. These bonds are polar because carbon is more electronegative than, chlorine is more electronegative than carbon. So bonds are not polar. But the molecule as a whole is non-polar. The dipole moment equal to 0. Here also dipole moment equal to 0. Because the electronegativities of two iodine atoms are same. Therefore, this is also non-polar. Therefore, again in the previous example we have studied the force of attraction between two non-polar molecules is always London dispersion force. Therefore, here also, since iodine and carbon tetrachloride both are non-polar, therefore the force between them is also London dispersion forces. Coming to the next one, sodium chlorate NaClO4 is an ionic compound and gives Na plus ClO4 ions in the solution. So NaClO4, it is important, it is an ionic compound and forms these ions in the solution. And water is a polar molecule. That means here the interaction will be between ion and a polar molecule. So ion dipole type. It is, the interaction must be ion dipole type. So this is anion, for example ClO4 minus. Therefore water positive pole will attract or will attach towards it. You see, positive pole is hydrogen. Del plus, del minus, del plus. Therefore what will happen? This is ClO4 minus. There will be attraction between the positive pole of water and then with the anion. Or sometimes here Na plus, if oxygen is this side, then what will happen? There will be attraction between the negative pole of water molecule and cation. Both these type of attractions are known as what? Ion dipole attractions. Therefore, between ions and a polar molecule, this type of interaction always occurs. Coming to the fourth one, here we have methanol and acetone. Methanol is CH3OH. It is a polar molecule. It is a polar molecule like water. Similarly, acetone, CH3, CH3. So this is also a polar molecule. Therefore, this interaction is between polar and polar molecule. Therefore, polar molecules are always dipole. For example, you see here HCl, the negative pole of one molecule attracts the positive pole of the other molecule. This is a type of electrostatic attraction, and this is dipole-dipole interaction, because one molecule is a dipole and the other molecule is also a dipole. Similarly, here methyl cyanide and this is acetone, C3H6O means CH3CO CH3. So this is also, both are polar molecules, therefore this interaction is also dipole-dipole type, like the previous one. Hope you understood. Thank you.